Every living and dynamic process in nature involves the conversion of energy from one form to another. These transformations are important for powering the machines that man builds and uses. This causes ocean current, rain, wind, temperature variations, and all other phenomena related to Earth's climate. The focus points for this lesson is at the end of this module, the learner will be able to, first, identify and explain the factors that affect potential energy and kinetic energy. At the end of this module, you're going to answer the essential questions, which number one, if energy can neither be created nor destroyed, where does it came from? And number two, why do we need to conserve energy when it is indestructible? Forms of energy. All forms of energy fall into two categories, potential and kinetic energy. Potential energy is stored energy or energy in position. For example, in case of the falling ball, it's going to be gravitational potential energy, which is the energy that comes from how high the object is. The second one is kinetic energy. This is an energy in motion. Any object that produces motion is called kinetic. Now in this lesson, we're going to learn how to calculate kinetic and potential energy. First, in kinetic energy, we use the formula as kinetic energy equals 1/2 times mass of the object times velocity squared. Now let us remember this. K is the energy in joules, M is the mass in kilograms, and V is the magnitude of velocity meter per second. Since mass is never negative, and B squared will always yield as a positive result. A body's kinetic energy has only two possible values, 0 and positive. Kinetic energy is 0 when the object is not moving, and positive when the object is moving. When using the above equation, you must understand the following points. 1. Kinetic energy is directly proportional to mass. If you double the mass, then you double the kinetic energy. Second, the faster something is moving, the greater energy it possesses. Number 2. Kinetic energy is directly proportional to the square of its speed. That means that for a twofold increase in speed, the kinetic energy will increase by a factor of 4. For a threefold increase in speed, the kinetic energy will increase by a factor of 9. Thus, a modest increase in speed can cause a large increase in kinetic energy. Number 3. Kinetic energy is scalar. Kinetic energy is a scalar quantity. It does not have a direction. Unlike velocity, acceleration, force, and momentum, the kinetic energy of an object is completely described by a magnitude alone. And now let's proceed for the sample problem and its computation. For kinetic energy, number 1, a 70-kilogram girl is running at about 10 meters per second. The question is, what is her kinetic energy? The given are 70 kilogram per mass and velocity is 10 meters per second. Let's transpose this using the formula shown here. Now, kinetic energy equals 1/2 times 70 kilogram times 10 squared. Just multiply first the given velocity, which is 10, and multiply by itself, then you will get 100. After multiplying the given velocity, the answer should be multiplied to the given mass, which is 70 kilogram. After getting the answer from that step, proceed by multiplying your answer to 1/2. Then you will get the kinetic energy, which is 3,500 joules. Let's proceed in potential energy. We've learned that potential energy is a stored in object due of position or configuration. For example, an object headed up high, like the hammer, has a potential energy. When it goes down, it creates motion, which is called kinetic. A compressed spring has a potential energy. Stretching a rubber band has a potential energy. What is common denominator from the following objects? Either the object is headed up high or the object is compressed and stretched. Therefore, we can say that there is a change in position and configuration in the object involved. Remember that all of this object has a potential energy waiting to be released. On the other hand, gravitational energy is the energy possessed by an object because of its position. It is also depending on the height of an object relative to a reference point. It is computed as gravitational potential energy equals mass times gravitation times height, where gravitational or PE grav is the amount of gravitational potential energy in joules, m is the mass in kilogram, g is the acceleration due to gravity, which is 9.8 meters per second, and h is the height relative to the reference point in meters. And now let's proceed for the sample problem and its computation. A 400 kilogram roller coaster car starts 48 meters above the ground and is 3 meters above the ground at the end of the ride. Calculate the change in potential energy of the car. Let's substitute all the given to the formula in getting the gravitational potential energy. If there is two given height in the problem, first, get the final height, then minus the initial height. After subtracting the initial height to final height, the answer will be multiplied to a gravitational force which is 9.8 meters per second. The next step, get the answer, then multiply it again to the given mass which is 400 kilogram. Then you will have the answer which is negative 176,400 joules.